Okay, something must have happened, but back on chapter 5, this is the problem 13. We were just finishing it, and we're down to the very last one, I believe, which is letter E. So they say, if a graduate student is selected, that's your margin, and the two joints we're looking for is skiing and ice skating. So let's go back up and look at graduate student, and let's find that's going to be my denominator. So that's going to be 180. That's my margin, and we want skiing or ice skating, so 74 and 47. So you add these two together and divide by 180. So again, to get that last one, I'll just kind of mark it up right here. You take 74 plus 47, that's our two joints. My one margin is the graduate, that's the given, that's our margin. Divide that by 180, and then that should give you your answer on part E, which is about 0.6722. And of course, down below, you can see the illustrating that right there. All right, so that would take care of problem 13. All right, the last three is going to be all Bayes' theorem. Let's check out number 14. And so they give us our Bayes' theorem. Now, what I did is I like to do what they call is the tabular approach. So what I did is I set all of these numbers up. I set all these numbers up in a table. And then when they say find the probability of A3 given B1 and so forth, I'll show you how I get that 0.3636 using a table. Here's the formula. I've often found students get confused by looking at it, but when I show it in a table format, they tend to like that a little bit better. So let me get to that. All right, so here's my Bayes' theorem. And this is problem, I believe, I guess this is problem 14. Oh, here we go. So notice what I did. Get my stylus. So notice I got one column. I got A1, A2, A3. That first column I call your margin. So you got 0.2, 0.4, and 0.4. Notice these always add up to 1. And then they gave us a condition. In this case, the condition, they just said B1 given A1, B1 given A2, and so forth. So I plug these numbers in, 0.25, 0.05, and 0.1. And then what you do is you multiply these two together, margin times condition, gives you the joint. That's your part of your formula. And then again, if you're wondering how they derive that, let me write this out. So your original formula is whenever you go the probability of A1, or this is the probability of A given B, which is defined as your intersection divided by your margin. So what happens is whenever you move this over to this side of the equation, what you get is you'd get the probability of B multiplied by the probability of your condition also equals your intersection. So that essentially is what Bayes' theorem is doing. So this is your margin, you multiply by your condition, this gets you back to your joint. And so once you get your joints, then you got to do what they call the posterior. You just take the individual joints and divide by the sum of your joints. So you take 0.05, divide by 0.11. You take 0.02, divide by 0.11, and 0.04, divide by 0.11. You do that individually, and then eventually what you get is you get your posteriors, 0.455, 182, 364. This is your updated condition. And in this particular problem, they want to look like it was the probability of A3 given B1. And of course, I show these three decimals. Let me increase that. Let me get back. The answer they put is 0.3636, which is this one right here. So just to show you, if I increase that, that would be the answer they're looking for. So that's how you use it. It's called the tabular approach. So once again, this is how I always work my Bayes' theorem. You got your margins, which always add up to 1. They'll give you the conditions. You multiply the first two together to get back to your joints. That's based on this conditional formula rule. Once you get your joints, it's going to be the individual joints divided by the sum of your joints. That's going to be called your posteriors. And again, these also should add up to 1. All right, so that is problem 14. Let me get back to the screen so you know where I'm at. And as you can see right here, that's going to be your answer for number 14. All righty, 2 more. Let's check out number 15. And again, this is another Bayes theorem. So in this case, we've got where they play 70% of their games at night, 30% during the day. So there's your two margins. Night games and day games adds up to 100%. The condition is going to be winning. They win 50% of their night games and 90% of their day games. And then they want to figure out the condition they won yesterday, the probability if they played at night. So again, let me show you my table. Let me go back to my screen. I already set this up in an Excel book for you. So this is problem 15. So again, notice very simply, all I did was, I've got, here's my margin that was given, and then here's the win condition, right? 50 and 90. So you got 50% of night games you win and 90% of day games. I multiplied the margin times the condition to get the joint. So 70 times 50 is 0.35. 30 times 90 is 0.27. You add those up, and then you take the individual joints, divide by the sum of the joints. So 0.35 divided by 0.62, you get 0.5645. And that's essentially saying, given you won, and they want to know the probability you played at night, there would be a 0.5645 probability. So I'll go back to the screen and show you that's what they're doing. And down below, what I just did in the table format is what they're showing right here. I feel like the table format's easier to follow, but that's where I came up with that 0.5645. If they played therefore during the day, it'd just be the complement, be 1 minus that, if that's what they're asking for. All right. Okay, one more, last one, last Bayes theorem problem. This is 16. And on this one, it looks like they give us 3 margins. You got cash sales, credit sales, and debit card sales. Notice 30 plus 30 plus 40 gives you 100%. And then the condition is going to be if they spent more than $50. So again, let me show you my table, how I set this up. So you'll notice, here's my 3 margins. Notice that adds up to 1. Here's my condition of spending more than $50. I plug those in just as given. So you multiply margin times condition. Here's my joints. And then my posteriors would be 0.06 over 0.57, 0.27 over 0.57, and 0.24 divided by 0.57. You plug those right there. I'm showing that the posteriors add up to 1. And of course, in this problem, they want the probability that you paid with cash, spent more than 50 bucks. The answer would be 0.105. That's your posterior that they're looking for. So let me go back to show you this. And of course, you can see on the screen, that's where they came up with this. Here's the formula that they would be using. And again, you're welcome to use the formula as is. Again, I like to use what they call the tabular approach. Okay, guys, that's the part 2 of your chapter 5 homework.